Okay, in this video, we will go over inverse trig functions and we will solve two problems. These two problems are slightly more difficult. The first one is this. We want to find the sine inverse of sine 7 pi over 6. Next one we have is cosine parentheses sine inverse of negative 5 over 7. Negative 5 over 7, we don't have an actual special rule for it, so we need to do something different. So let's get started with this one. So we have sine 7 pi over 6. So the first step that we need to do is pretend we have sine pi over 6. So we're pretending we have sine pi over 6. And sine pi over 6 would be 1/2. However, we have sine 7 pi over 6. And so if we use our reference table, we know that we're in this quadrant. We are in quadrant 3. And for quadrant 3, the only thing that's positive is tan. Sine's negative, cosine's negative, and so sine 7 pi over 6 would be negative 1/2. And so now we have sine inverse negative 1/2. And so we need to find out how can we possibly get 1/2. We ignore the negative temporarily. So how can we get 1/2? What value of sine, what angle of sine would give us 1/2? And if we look at our table, it would be pi over 6, since sine pi over 6 would produce 1/2. And so the next step, we need to choose what angle. And the way we choose the angle is we use this reference table, inverse trig functions. And so we know that inverse sine can only go from negative pi 2 to pi 2. So it could only be in quadrant 1 or quadrant 2 and quadrant 4. And since we technically have a negative 1/2, we're going to want the negative 1. And just to recap, we're saying in order to get 1/2, it needs to be pi 6. But in order to get negative 1/2, it needs to be negative pi 6. Because based off our reference table, we know that quadrant 1 is positive for sine, cosine, tangent. It's positive for everything. And our only options are this quadrant and this. And quadrant 4 is only positive for cosine. It's negative for sine. So we want the negative one. And so our answer would be negative pi 6. And so now we will do the second question. Second question is a little bit more difficult since the only options are 1/2, square root of 2 divided by 2, square root of 3 divided by 2. Nothing like 5/7. So we can't use this table. So first we want to get the sine inverse of negative 5 over 7. And we know that sine inverse the angle can only be from negative pi 2 to pi 2. And so we say that sine theta is equal to negative 5 over 7. So sine theta is equal to negative 5 over 7. And so we're going to draw our angle. And we know that sine is opposite over hypotenuse. So this is our angle. Opposite is negative 5. And hypotenuse is 7. We know it's going to be in this quadrant because we have a negative 5 over 7. And we know that sine is negative in this quadrant. So that's why we're choosing this quadrant as opposed to this quadrant. So next we want to get a. We want the value of a. So since this is a right triangle, we know that a squared plus b squared is equal to c squared. So a squared plus parentheses negative 5 squared is equal to 7 squared. So we can say that a is equal to the square root of 7 squared minus 5 squared. And this would produce the square root of 24. We know that 4 times 6 is 24. So we could say that this is 2 square root of 6. So we're almost there. So now we know a. And we know that cosine is adjacent over hypotenuse. So it's going to be a over hypotenuse. And so it would be 2 square root of 6 divided by 7. Since this is a positive number. Another way to think about this is that if we use our reference table, we know that in this quadrant, cosine is positive. So that's another thing to consider. So our final answer would be 2 square root of 6 divided by 7 because we discovered the a value is 2 square root of 6 and our hypotenuse is 7. And that's all we need to do to solve inverse trig functions, whether it fits nicely with this table or if it's something different.